Welcome to our online chemistry class. Our topic is aldehydes, ketones and carboxylic acid. Let us discuss the part number 2 of this topic. In this part, we will discuss the general method of preparation of aldehydes and ketones. First method is by oxidation of alcohols. So primary alcohol on oxidation with PCC, that is pyridium chlorochromate, it gives aldehyde by loss of water, while secondary alcohol react with chromic trioxide gives ketone by loss of water. So for example, ethyl alcohol is a primary alcohol, react with PCC, it undergo oxidation. Oxidation means simple loss of hydrogen with this oxygen generated due to PCC. So one hydrogen from OH and one hydrogen from this carbon containing OH group get removed as a water, and there is a double bond between these two atoms, that is carbon and oxygen, and we get a function group CHO because your alcohol is primary alcohol. This carbon contains two hydrogen, we get a aldehyde, and here from ethyl alcohol we get acetaldehyde. IUPAC name is ethanol. While isopropyl alcohol, which is the secondary alcohol, contains OH group on secondary carbon, and that carbon contains only one hydrogen. So if it undergo oxidation by using CrO3, then the hydrogen from OH group and this secondary carbon get removed with this oxygen, and it gives a double bond between carbon and oxygen, and that is a acetone as a product. So here the secondary carbon contain only one hydrogen, so this carbon does not contain hydrogen after loss of that hydrogen. So function group is C double bond O, so it is a ketonic functional group. So isopropyl alcohol gives acetone dimethyl ketone as a product, or propane 2-one is the IUPAC name of acetone. So this reaction we already discussed in the previous topic, just it is a revision. Then next one is by dehydrogenation of alcohol. Instead of that PCC CrO3, we can use copper, but for that purpose we have to maintain the temperature to 573. Again your reactant and products are same, reaction is also same. So primary alcohol gives aldehyde, secondary alcohol gives ketone, and we can use same example, or you can take another example of primary and secondary alcohol. Okay, so dehydrogenation, that is means oxidation, only the change is the reagent is copper at 573 Kelvin, it is also a oxidation. Next is from hydrocarbons. So this reaction you already learned in 11th standard by ozonolysis of alkene. So when any alkene react with ozone O3 in presence of organic solvents such as carbon tetrachloride, first that 3 oxygen atom of ozone get added across the carbon-carbon double bond, and we get a structure like this, and that compound is called as ozonide of that respective alkene. Then this ozonide undergo hydrolysis in presence of zinc, and then there is a breaking of this carbon oxygen bond like this, and we get aldehyde or ketone. So your product formation is totally depends on your alkene. Okay, if your alkene contain at least one hydrogen on each carbon of the double bond, then we get aldehyde. If it does not contain hydrogen, it contains only alkyl groups, then we get a ketone as a product. So let us see the example. So for example, ethene react with ozone Ethene contain two hydrogen on each carbon of the double bond. So ozonide is ethene ozonide, and if it undergo hydrolysis, in this way there is a breaking of bond. Then what we get? Now each carbon of the double bond contain two hydrogen. So simply you have to break the double bond and place their oxygen on each carbon of the double bond. So what we get? CH2 double bond O, and here HCH double bond O. So as your ethene is a symmetrical alkene, if you pass a plane through this carbon-carbon double bond perpendicular to this double bond, then we observe identical groups on both sides. So we get same compound, and here each carbon contain two hydrogen. So aldehyde is formaldehyde, methanol from ethene. Okay, so here both the hydrogens are present, so we get formaldehyde. Let us consider the another example. In this example, we observe if you pass a plane through this carbon-carbon double bond, your double bonded carbon contain different groups. So here on this carbon of that double bond contain two methyl group, but the second carbon of the double bond contain one methyl and one hydrogen. So simple technique is that simply break the double bond and write down oxygen on each carbon of the double bond with double bond. So what we get? CH3 C double bond O CH3. So see the product. It is acetone, dimethyl ketone, propane to one, and second one is place here double bond with oxygen on this carbon. So this carbon contain one CH3 and H. So CH3 C double bond O H means CHO. So it is acetaldehyde ethanol as a product. So in this way you can easily write the final product. So one more thing that you must note down is that here in the second step zinc is used. So if it doesn't use the zinc, your byproduct here H2O2. So this one oxygen out of these three react with your oxygen, and that H2O itself undergo oxidation to H2O2, and it is a good oxidizing agent, and due to that your aldehyde or ketone undergo further oxidation. To avoid that step, we have to use opposite agent of that H2O2. H2O2 is an oxidizing agent, so we have to use reducing agent, and that's why we use zinc. So when we use zinc, zinc react with that oxygen and it gives ZNO. So here H2O2 is avoided, and which cannot be further oxidize your aldehyde or ketone. That is the use of zinc. Then next reaction is, and you can try for different types of alkenes, symmetrical or unsymmetrical, and check the product. Now next reaction is by hydration of alkenes. Hydration means addition of water. So here alkyne is the reactant. So alkyne react with water in presence of 40% concentrated sulfuric acid and 1% mercuric sulfate HgSO4, and it gives aldehyde and ketone. So depends on your alkyne, your product will be formed. So if your alkyne contain hydrogen on both the carbon of the double bond, then and then we get a aldehyde. If at least one carbon contain alkyl group, then we can't get a aldehyde. So check the reaction. So first member of your alkyne is ethyne or acetylene, react with water in presence of 40% H2SO4 and 1% HgSO4. So these two chemicals generate the water. And what is the simple method? So H2O can be written as HOH, and you can add OH to one carbon of the triple bond and H to another carbon of the triple bond, and convert the triple bond into double bond. Break one bond between two carbon. So what we get? We add the hydrogen to first carbon then one hydrogen is already there, so CH becomes CH2, triple bond gets converted to double, CH becomes CHOH. Okay, so in this compound your two carbons contain a double bond and one carbon of that double bond contain OH. So one compound contain two functional group on same carbon. So such a carbon is called as vinyl carbon, and OH is the functional group. That's why the compound is vinyl alcohol. So we already discussed this in the classification of alcohols, and such compounds are unstable, so it undergo conversion into a stable product. So only the shifting of hydrogen from OH group, so this hydrogen from OH group get shifted to this carbon, CH2 carbon. So if first we have to break the OH bond and convert the CO bond to CO double bond, and then this carbon becomes pentavalent, make tetravalent, then this double bond between two carbon gets converted to single bond, and by simple shifting of this hydrogen to CH2 carbon, CH2 becomes CH3, and here there is a double bond between carbon and oxygen, so we get a aldehyde, and this conversion is called as tautomerism or tautomerization. Okay, so these two are one different types of isomers, and that isomer is called as tautomers of each other. Process is called as tautomerization because your vinyl alcohol is unstable. So if we take ethyl ethine or acetylene, then we get acetaldehyde. So we can't prepare formaldehyde by using this method. If we take 3 carbon alkyne, that is propyne, it undergo hydration by using same reagent, 40% HgSO4 and 1% H2SO4. Add, now you have to add you can add your reagent to your alkyne, but if you observe this alkyne and if you pass a plane through carbon carbon triple bond, then first carbon of the triple bond contains CH3 group, second carbon of the triple bond contain H group, so it is not symmetrical. So you can add like this. So I'll write H2O like this, H dash OH. Okay, so all are familiar with this. OH is the negative part of the reagent, so you can add where we add the negative part, where we add the positive part, that we have to check. So I'll write OHH, and remember that OH is the negative part, so oxygen is more electronegative than hydrogen, so OH is the negative part, hydrogen is the positive part. So this addition takes place according to Markovnikov's rule. So negative part OH get added to that carbon which contain lesser number of hydrogen of that triple bond. So reaction takes place according to Markovnikov's rule. So you can add like this, OH get added to this carbon and hydrogen gets added to carbon contain more number of hydrogen. In this way addition will takes place and reaction takes place according to Markovnikov's rule. Reaction takes place according to Markovnikov's rule. Okay, so remember this, then it is very easy to write the correct product. Okay, so you have to follow the Markovnikov's rule. So check OH is added to second carbon and hydrogen is added to first carbon. So numbering is like this: 1 2 3. Okay, so CH become CH2, triple bond gets converted to double bond, OH is added to this carbon, so here is the OH. Now it is also unstable, so it undergo rearrangement. So I write the convergence. So the bond between H and OH so in this way the bond between H and OH get shifted to carbon oxygen double bond. So if write here double bond between carbon and oxygen like this, then this carbon becomes pentavalent because already there are 4 bonds. So for that purpose again there is a shifting of this double bond to single, and it is like this. Okay, so in this way shifting of bond takes place, and in short this H gets shifted to this carbon. So what we get? CH3 C double bond O CH2, and this H become CH3. So what is your product? Your product is acetone. Okay, we get acetone, and your intermediate is this carbon is carbon number 1, this carbon is 2, this is 3. So prop in 2 OL, double bond on first carbon and OH on second carbon, and your product is acetone. Okay, ketone is the product. So remember this hydration, already learn. Then next reaction is from acyl chloride. What is acyl chloride? RCOCl. Dash COCl is the functional group of acyl chloride. So first change is, so what is the change? C double bond OCl gets converted to C double bond OH. So this Cl get replaced by H, and there is a specific name that is called as Rosenmund reaction. It is replacement of Cl by H. So you add the hydrogen, so it is reduction reaction. So Rosenmund reduction. So we use hydrogen, and catalyst is palladium is added over barium sulfate Pd in presence of BaSO4. So replace the Cl by H and we get aldehyde. So benzoyl chloride C6H5CO, that group is called as benzoyl. It is not phenyl because CO group is in between your carbon of that ring and Cl, so it is a benzoyl. If it is there is no CO group, and if it is C6H5Cl, H5Cl, then it is phenyl chloride or chlorobenzene. Okay, so understood the difference between phenyl chloride and benzyl chloride. So benzyl chloride undergo Rosenman reduction. It gives simply replace the Cl by H. So C6H5COH means CHO. Don't write like that. You always write C double bond OH or CHO as a function group of aldehyde. So what is your product? Benzaldehyde. Then preparation of aliphatic and aromatic ketone from acyl chloride. So to prepare that, we use RMGX or Grignard reagent. Alkyl magnesium halide is called as Grignard reagent. So that react with CdCl2 cadmium chloride, and it gives dialkyl cadmium, okay, as a main product. And check the reaction. For example, acyl chloride react with that dialkyl cadmium, and it will give ketone as a product plus cadmium chloride. So this chlorine get replaced by alkyl group, okay, and cadmium react with chlorine to give cadmium chloride. So we require dialkyl cadmium, and it is generated using the Grignard reagent. So that is the use of Grignard reagent. So for example, to prepare acetone, acetone contains two alkyl methyl group attached to carbonyl carbon. So your reagent dimethyl cadmium react with acetyl chloride. If R is CH3 COCl, then the compound is called as acetyl chloride, is the common name. It is also known as ethanol chloride, which is the IUPAC name. What we get? The Cl get replaced by alkyl group is CH3. So CH3CO CH3. Check the product. So your product is propanone or acetone or dimethyl ketone plus CdCl2. If you have to prepare acetophenone, acetophenone contain C6H5 and CH3 group attached to carbonyl carbon. So you have to select dimethyl cadmium as a reagent, and it react with benzoyl chloride. So your product is acetophenone. Okay. So, or what is the common name? Another name. So alkyl group is phenyl and methyl, and aryl group is phenyl. So methyl phenyl ketone is the another name of acetophenone. So this is about the reaction. Then you can prepare from alkyl cyanide or nitrile. So when alkyl cyanide react with dry ether in presence of alkyl cyanide or alkane nitrile. Alkane nitrile is IUPAC name of your cyanide. On addition of hydrogen means reduction. So nitrile or cyanide are reduced to imine hydrochloride, and that imine hydrochloride on acid hydrolysis gives corresponding aldehyde. Okay. So first your cyanide or nitrile react with reducing agent essential to stannous chloride. So essential to react with HCl, it gives essential 4 plus hydrogen. So that hydrogen is used for reduction purpose, and that react with your cyanide or nitrile. So first convert the triple bond into double. So add the hydrogen to carbon nitrogen triple bond. So one hydrogen is added to first carbon and another hydrogen is added to nitrogen. So CH double bond NH HCl. Okay, and then you have to undergo hydrolysis of that imine. So carbon nitrogen double bond, if it is the functional group, the compound is called as imine, and it is basic in nature, so it is balanced by HCl, which is the acid. So name of the compound is imine hydrochloride, and then it undergo hydrolysis in presence of acid, means H2O oblique H plus, that is H3O plus, your compound. So break the carbon nitrogen double bond, add oxygen to this carbon and hydrogen to nitrogen. So first OH is added to CH, convert the double bond into single bond by adding hydrogen to NH. So your compound become RCHOH dash NH2. Okay, so we get a compound which undergo further rearrangement. So hydrogen of that OH get transferred to this NH2, and NH2 become that NH2 become NH3 plus this HCl gives NH4Cl, and we convert your single bond OH to double bond O with carbon. So we get RCHO. Okay, so I think all of you understood the convergence, and we get a aldehyde as a product. Okay, so let us see the example. If R is CH3, then methyl cyanide or acetonitrile, or IUPAC name is ethanonitrile, on reduction. So add hydrogen to carbon nitrogen triple bond. What do we get? CH3 CH double bond NH HCl. So it is 2 carbon. So ethane replace E by imine, ethanamine hydrochloride, or your compound is acetonitrile. So and your product is acetaldehyde. So acetaldehyde, acetal-imine hydrochloride, on hydrolysis simply break the carbon nitrogen double bond, place a double bond with oxygen to this carbon, and add 2 hydrogen to this carbon. So what we get? NHCl becomes NH4Cl, and CH3CH become CH3CH. We get ethanol or acetaldehyde product. Okay, you can try for changing this alkyl group. And if we write C2H5 here, tell me the product, write down this product and write down that in comment box. Then benzonitrile or phenyl cyanide, this one on reduction gives benzenamine hydrochloride, and finally we get benzaldehyde. So only change the alkyl group attached to alkyl or aryl group attached to CN functional group and write down the corresponding product. We get a aldehyde by using this. Okay, because we can add only one alkyl group to CN functional group because there is a carbon nitrogen triple bond. So always we get a aldehyde as a product, either aliphatic or aromatic, depends on your alkyl or aryl group. So unsaturated nitriles are reduced by using specific strong reducing agent, that is diisobutyl aluminum hydride, which can be written like this: DiBAlH Okay, that is the short form of this reagent. It gets converted into first imine, and which on hydrolysis by using acid, that is acid hydrolysis, it gives a aldehyde. Okay, so pent 3 in nitrile is the compound. It undergo reduction by using diisobutyl aluminum hydride. It gives pent 3 enol. Okay, then so I think all of you understood the reagent. And what is the important thing? The double bond between two carbon get maintained. This double bond cannot be reduced, and that's why we have to use diisobutyl aluminum hydride. If you use the previous reagent, it can reduces this double bond also. But if we have to prepare unsaturated aldehyde, then we can use diisobutyl aluminum hydride. So remember this for the point of view with respect to your CET exam. Then next one is preparation of ketones from nitrile. Again same is the reactant, but by using Grignard reagent. Okay, so here we use the Grignard reagent, and here is the reaction. Ethane nitrile or acetonitrile or methyl cyanide react with. So it depends on your product. If you have to obtain acetone, take methyl group in your Grignard reagent, methyl magnesium chloride. Reaction takes place in presence of dry ether. So how will you write the product? So negative part is CH3, CH3 is the negative part of your reagent. So and MgCl is the positive part. So CH3 will attack on less electronegative group of your functional group. So among the CN, nitrogen is more electronegative than carbon. So CH3 will attack on less electronegative. That means electron deficient group or electron deficient center. Okay, so CH3 is the negative part, it will attach to carbon of the nitrogen cyanide group, and MgCl, which is the positive part, get attached to more electronegative nitrogen. So this triple bond get converted to double like this. In this way there is a breaking of bond, triple bond gets converted to double, and this negative part attract the MgCl. So to get, we get a complex, it is unstable, and it undergo hydrolysis. So to carry out the hydrolysis, we have to break the bond here like this. We have to break a double bond here. Okay, and we can add a group HOH. So again nitrogen is more electronegative, so add hydrogen to nitrogen, and OH to this carbon. So before getting your final product, you got CH3 CH C CH3 OH, and double bond gets converted to single. Add hydrogen to this, then that OH hydrogen gets shifted to your nitrogen, and we get NH3. Okay, so what we get? CH3 C double bond O CH3. So what we get? Acetone. Then N become NH3 ammonia, and byproduct is MgClOH. Okay, so in short, simply convert the carbon nitrogen triple bond to carbon oxygen double bond, and add your alkyl group from Grignard reagent to carbon of the triple bond with nitrogen. So what is your product? Benzonitrile phenyl cyanide react with phenyl magnesium bromide. Simply add this phenyl group to this carbon of the triple bond with nitrogen, this cyanide group carbon, and convert the CN to C double bond. So check the product, and nitrogen gets converted to ammonia. Byproduct is MgBrOH. So we get a benzophenone as your final product. So here we get a imine which is unstable. It undergo rearrangement to corresponding ketone NH3 and MgBrOH. Okay, so I'll show you how these changes will take place. So just before that, I have to add H2O. O dash H, that is H3O plus. So plus charge is there. Okay, so here OH2 plus, okay. So first this OH will attack on this carbon, and H will attach to this. So before that, this nitrogen form. If we attach OH2 to this carbon, and carbon becomes pentavalent. To mix tetravalent or to convert into stable product, and that is double bond gets converted to single, and then you can add this hydrogen, this nitrogen, like this. Okay, so OH2 is added to this carbon and hydrogen is added to this. What we get? C6H5 COH2 single bond NH, and then again break the bond between two carbon and oxygen, carbon and oxygen and hydrogen, and transfer that hydrogen to NH. Okay, so to get benzaldehyde plus NH3, so you can write it like this, that hydrogen kept away, only add water, first OH, and then transfer this, write down here H plus, that H plus react with this NH and it becomes NH3. Okay, after shifting this hydrogen to nitrogen. So in this way you can write your product. Then next is the retard reaction. Here we have to prepare aromatic aldehydes. So toluene react with chromyl chloride in presence of organic solvents such as carbon disulfide. It gives chromium complex, which is brown in color. Simply replace these two hydrogen by OCr-OHCl group, which is unstable, and it undergo hydrolysis. So by simply breaking these bonds, okay, so convert this carbon is already tetravalent. If we make one carbon oxygen double bond, then we have to break the another carbon oxygen bond. So and byproduct is CrO2Cl2 plus water. Then second one is by oxidation of methyl benzene or toluene. So reagent is chromium oxide CrO3 and acetic anhydride. So again these two hydrogen get replaced by CH3CO group. So it is acetate group. So if acetic acid is added in water, it gives CH3COO minus plus H plus. So that is the acetate group, and it undergo hydrolysis again in the previous manner. So we have to break like this. So first we have to break the bond between carbon and oxygen, and it form a double bond with this carbon. Okay, like this. So if we write a double bond like this, then this carbon becomes pentavalent. So we have to break the next carbon oxygen bond. So this, and this oxygen form a bond with this carbon. Okay, in this way. So what we get? CH3CO OCO3. This is your product. Again, we get a anhydride, acetic anhydride, and double bond with this carbon. So C double bond OH CH. Similarly, here also you can write the same method for writing your final product with byproduct. Then third one is by side chain chlorination of toluene followed by hydrolysis. This is a commercial method for preparation of benzaldehyde. So toluene or methyl benzene react with chlorine in presence of UV light. What we get? These two hydrogen of CH3 group get replaced by 2 chlorine. So write down here 2Cl2. Byproduct is HCl, which is removed, so minus HCl. So what we get? CHCl2 benzyl chloride. Actually it is benzyl dichloride because there are 2 chlorine, so make it correct in your book. Which on hydrolysis, so break the bond between carbon and Cl. Again 2 Cl get replaced by 2 OH, so CH OH OH, one carbon contain 2 OH group, that is unstable. It undergo rearrangement and it gives CHO plus H2O. So that H2 is obtained and this 2 Cl get replaced by OH, that's why minus 2 HCl. So in this way we obtain the benzaldehyde product. Then Guterman-Koch reaction, when benzene is treated with carbon monoxide in presence of hydrochloric acid and anhydrous AlCl3, so CO group is added in between carbon and hydrogen. So we get CHO plus HCl is the byproduct. So remember the name reaction. Then your reaction is Friedel-Crafts reaction. This reaction you already learned in 11th standard under the heading of aromatic compound. Benzene react with acetyl chloride CH3COCl in presence of anhydrous AlCl3, which acts as Lewis acid and catalyst. So the hydrogen of benzene get replaced by COCH3 group. That's why the name is acylation. So COCH3 group plus HCl is the byproduct. So when acetyl chloride is the reagent, product is acetophenol. And preparation of aldehyde from ester. When ester react with diisobutyl aluminum hydride DiBAlH, simply break the bond between C double bond O OR, that is CO bond, and write down hydrogen to this carbon and convert this into COH. Sorry, here byproduct is R alcohol, ethyl alcohol, not the acid. Okay, so remember that while writing any chemical reaction you have to use always balanced chemical equation. So here is the methods of preparation. Thank you very much.